Okay, so here I'm going to demonstrate the next part. So this is for lab 2. Just open it up. Okay, start with number 1. So here we've got our 5-volt DC power supply, and so the positive side is coming into both of these. So we've got 2 switches, but so we can turn one off and one on, vice versa, whatever. Here we've got the pull down resistors. And so those are pulling it down to eliminate some of the noise, to assure that it's either on or off. There's no really in between. So those are grounded. And then we've got ground and our LED. And so that also just protects the LED. This resistor could be before or after the LED, I think. But this is like an active low situation. So it comes before. And here we've got our NAND gate. And so how this should work is everything except when they're both on should leave the LED illuminated. So I think we've got another one running. Pause that. So if we run this, yes, so the LED is illuminated, stays illuminated, stays illuminated, and then when they both go, it turns off, as expected. Okay. So, same circuit, pull down resistors, switches, DC power supply, as expected. Um, and here we've got the NOR gate. And so the NOR gate, as OR would suggest, if one or the other is on, it will be on. But because this is inverted, then they both must be off for it to be on. So they're both off. So the LED is illuminated. And when either turns on, it will turn off, as we expected. Let's open up the next one. Okay, getting a little more complicated here. So we're taking the switch inputs and we're using that as both inputs to these gates. So once again, these resistors are acting as pull down resistors to eliminate some of that noise. So we've got 2 NOR gates. And so because this is the same, basically, if it's open, then this will be illuminated. And if it's closed, then, or sorry, not illuminated, there's no LED. If it's open, the output of this will be high. And if it's closed, the output of this will be low. And that will be the same for this. And so, whatever comes into here, similar situation, they both want to be low for this to be illuminated. So if we have both these open, then we should get high, high. This would have been high, then switches to low, so it'll be off. And as you can see, the LED is off. Now if we turn on one, stays off. And now when we turn on both, the LED is illuminated. So essentially, this is just a complicated AND gate, because both need to be turned on for it to turn on. So that's the function of an AND. So we could simplify this circuit to this circuit. They work the exact same way. Actually, sorry, not this one, because this is a NAND. This is just a simple AND gate. So we're done with that. And moving on to 4A. Okay, so here, once again, pull down resistor. So that's connected to ground on the input side here. And so we have our DC power supply. That's coming into our switch. And basically we want to see how the switch controls the AC signal coming in. So in this circuit, because it's an AND, so this will constantly be going high and low. And so because this is an AND, basically, unless this is also closed, the LED will be flashing. So let's leave it closed. Or sorry, unless this is open, it will be flashing. Okay, so this just leaves it in the state that it's in, which happens to be high when I keep clicking it. But so our AC signal comes in, and so that's a mixture of high and low. And then, so when we have this open, we have a 0 in, basically a 1. So that should be a 0, but it actually turns into a 1. Yes. So if this is closed, that's where basically this flows straight through. So the function of this is that when our DC switch is closed, we have a flashing LED, and when it's open, we have it stopped. Should be same thing, I believe, with the NOR gate. Yes. So same setup here, but this time it should essentially be the opposite. So when it's open, it'll be flashing, and when it's closed, it'll pause it. So when it's closed, this is paused. So originally it started in the off state. Because it's switching very fast, it just tends to go high. So when it's open, oh, there we go. So when it's open, oh, you know what? I bet this is because this doesn't have a pull down resistor. Let's try this again. Sorry, quick detour here. Just want to see what happens. It flashes. No. Yeah, no, it stays on after. Consistently high. Oh, because this would be a 0 coming through. This would be 1, so the output will always be 1. Although this should flip between. Okay. This is what it was. So what happens is, no matter whether this is 0 or 1, it will always cause this to be high because they're not both high. When they're both high, you see a flipping switch. But if this one is 0 and this one is 1 or it's 0, that triggers it because a NAND gate is always triggered unless they're both high. And that's why you see the flashing. And so the reason it flashes is because this is high, this one is high, and this one is high and then not high. So that causes the flashing. It makes more sense. And then this one, similar, but with the OR, so when it's open, then you get the flashing. Otherwise, because they're both high, that gets canceled out. Okay. And yeah, that's everything. So that demonstrates all of the circuits that we've built in Lab 2.